Welcome back, everyone. This is part 2 of section 10.2. We're going to talk about arc length. And if you remember, our arc length formula is here. And when I derived this for us, we actually started here because it's actually just a giant Pythagorean theorem issue. So here we are in parametric form. Notice the boundaries go from a to b when we're a function of x, but when we're x and y are both functions of t, we go from alpha beta, meaning alpha and beta are t values. All right, so let's do this. We're going to find the arc length of x equals cosine t, y equals sine t, where t is going from 0 to 2 pi. Now, I want to point out that this is the unit circle, right? X squared plus y squared is cosine squared plus sine squared, which is just 1. And so x squared plus y squared equals 1. This is the unit circle. And we know how to find the arc length of a circle. So hopefully this will work itself out. So I'm going to start out by digging this out. So dx over dt is negative sine of t. And dx dt squared is sine squared of t. dy dt is cosine t. Dy over dt squared is cosine squared of t. Which means if I take the square root of x prime squared, meaning this is x prime, this is y prime squared, we end up with the square root sine squared t plus cosine squared t, which is root 1, which is just 1. So my integral, my arc length, becomes the integral from 0 to 2 pi of 1 dt. Well, that makes it nice and easy. This becomes t from 0 to 2 pi, which is just 2 pi. Now we know the circumference of a circle is 2 pi r. And because this is the unit circle, r is just 1. So this is actually exactly what we would expect to get if we were to do it even geometrically. All right. Find the arc length of the cycloid. Now, we've talked about the cycloid several times. We get a lot of fun use out of this. So I'm going to have to do a couple of things. First off, I want to find, I'm going to call x is a function of theta, and y is a function of theta. So when I use the prime notation, I'm talking about with respect to theta, not with respect to one another. So x prime, it's going to be r times 1 minus cosine theta. X prime squared is r squared 1 minus cosine theta squared. Y prime is going to be r sine of theta. Y prime squared is r squared sine squared theta. So I'm actually going to FOIL this out for us. And I'm going to put this all under a radical. So I'm going to have that plus that under a radical. So square root x prime squared plus y prime squared. It's going to be the square root of, and since they both have an r squared, I'm pulling it out in front, r squared. It's going to be that 1 minus 2 cosine theta plus cosine squared theta plus sine squared theta. So a bunch of things are going to happen now. This turns into a 1. R squared, since r is positive, we're just going to pull that out in front, r square root of, and we are left with 2 minus 2 cosine theta. And I'm going to notice that, so r root 2 and then square root of 1 minus cosine theta. Now, I'm going to use this rule here. Actually, 2 theta. This one's going to, pardon me, this is theta over 2. Let me start that again. I'll go over here. Sine squared of theta over 2 is equal to 1/2 1 minus cosine theta. And if I knock that 2 over, I get 2 sine squared of theta over 2 equals 1 minus cosine theta. And that's what's going to happen to that there. So this becomes r root 2, then square root of 2 sine squared of theta over 2. And that root 2 times that root 2 just becomes 2r sine of theta over 2. Now I can justify not using an absolute value because theta over 2 only is going to be positive from 0 to 2 pi. Remember, that's going to double the frequency. So what happens is, because it doubles, 0 to 2 pi means that sine is only in quadrants 1 and 2, and sine is positive in quadrants 1 and 2. So we don't need that absolute value there. Okay, so let's get to the integral. So we have a whole lot of constants. So that's L equals 2r, integral from 0 to 2 pi of sine of theta over 2 d theta. Well, that simplified quite nicely for us. I'm going to get an extra 2 here, so I'm going to end up with a 4r, actually a negative cosine of theta over 2 from 0 to 2 pi. And that's going to get us negative 4r. And when I plug in 2 pi there, that's going to be cosine of pi. Minus, when I plug in 0 there, that's going to be cosine of 0. So we end up with negative 4r. Cosine of pi is negative 1. Cosine of 0 is positive 1. Be careful really with the negatives here. It's going to be really easy to accidentally, turn that into a 0 somehow or something. So negative 4r times negative 2 is going to be a positive 8r, which is super cool if you think about it. It's exactly the arc length, meaning if I were to walk along this here, I would walk a distance of 8, and then I would just need the radius of the circle that's wandering around there. Cool stuff. We got one more to go. And now we're going to be talking about surface area. And the formula for that, just like we did in a previous chapter, this is our ds, but written in terms of functions of t. Now, y is going to be a function of t in this case, of course. And we want to show that the surface area of a sphere is 4 pi r squared. And we're going to start here with a picture. And our graph is going to go from here to here, negative r to r. This up here, of course, is for a y value as well. And what we're going to do is we're going to rotate this around the x-axis. And that's where that formula comes in. And what we're going to do is we're going to find the surface area of this. Now, this formula here is a circle, and we know that a circle looks like this. However, in parametric equations, x is going to be our cosine of t, and y is going to be our sine of t. Where r, once again, is the radius here. So this exactly describes this here. You can see if you were to do this squared plus this squared and divide out the r squared, here you're going to end up with the unit circle. Oh, I'm sorry, with the circle with r squared as the radius. So here are our parametric equations. And I'm going to dig out this part first. So x prime is going to be negative r sine t, and x prime squared is going to be r squared sine squared t. Y prime is r cosine t, y prime squared is going to be r squared cosine squared of t. So the square root of x prime squared plus y prime squared is going to be square root r squared sine squared t plus r squared cosine squared t. If you factor an r out, and of course we know what that is. That whole thing turns into a 1. So this means it's just r, meaning all of this, all of that is just an r. Now y is y. So let's find our surface area. So 2 pi is here. The integral, now notice my integral only goes from 0 to pi. Notice I don't need to go all the way around, because when I go around the x-axis, that'll get the entire sphere. And this is going to be y, which is r sine t, times r dt. Remember, r is a constant relative to t in this case. So I'm going to pull the r and the r out to get r squared. So when I integrate this, I get a negative, because integral of sine is negative cosine. Cosine of pi is negative 1, minus cosine of 0 is 1. And negative 2 times negative 2 is 4 pi r squared. Super cool. And that is going to be 10.2 for us.